Recording in progress.
Yep. Comes on everyone. Did everyone try this? Anyone got an answer? Sure. Comes on everyone. Let's start off. Okay. Where are the remaining people? Did I send the link in the wrong group? Kya? No, right?
No, sir.
Anyone got an answer for this?
No, sir.
How do we approach this? See. So here the idea is, let this whole system be Px. Let the system be X. Now the idea here is, if I just ignore one block, and if I look at this part, so if we ignore one branch, it is still an infinite one, isn't it? It is still infinite pulleys. That means this is also X. That means when you took this block M, and you replace this whole thing with X, and now you're saying this whole thing must be also equal to X, isn't it? Is that making sense? If this is X and the whole thing is also X, so that means what is the equivalent of this? So M equivalent of this is 4M X by M plus X, but this is also equal to X. Is that making sense? That means when you solve this, X is equal to 3M. That means the entire right side pulley here can be replaced with one single block, M, and this can be replaced with 3M. So this is acceleration A, acceleration A downward. This is mg. This is 3mg. It becomes a two-block problem. Acceleration will be 3mg minus mg by 3m plus m, g by 2. Is the idea clear, everyone? See what I did. Let the whole thing be X. If I remove one branch, this whole thing is still X. So this whole thing in the red plus this blue block together must be this green one. And we know for two pulleys, a pulley and two blocks, the M equivalent is 4M1, M2 by M1 plus M2. We derived in the last class. So you're saying that this guy in the red and this blue guy must be again equal to X. So 4mx by m plus x must be equal to x. That means x is equal to 3m. So the whole thing is becomes simply a two-block problem, and you know how to do from there. Is this clear, everyone? Easy? Once you know the pulley equivalent method, it looks easy. Next one. This is M, 2M, 4M, 2M, and 3M. Find acceleration of the blocks. And let's call this P1 and P2 pulley. Find acceleration of the blocks and pulleys. How do we do this? The regular way of is like you can take T1 tension T, T1, T1, T2, T2, and then you can start solving. You get four FBDs, one constant equation solved. But you can use pulley equivalent and finish it off. That will be faster. Try. I'll give you a minute more. Acceleration of block 1 0. It's interesting. See. I can replace this whole thing with one block, which is 2m into 3m by 5m. So that would be 6m by 5. I can replace this whole thing with one block, which is m, 4m by 5m, that is 4m by 5. So this guy is as good as having two blocks, 4m by 5, 6m by 5. Agreed? And then the tension in the string T would be 6m by 5 minus 4m by 5 G, m2 minus m1 by m2 plus m1, 4m by 5. That would be 2mg by 5 by 2m. That's acceleration, my mistake. 2 m1 m2, so 4m by 5, 6m by 5 by m1 plus m2. How much is that? 6, 4, 24, 48 mg by 25. This is 10m by 2m. 1m will cancel, 2 will cancel. 24 mg by 25. That is the tension in the strings. Yeah, I need to multiply 4 in both the cases. Bhul gaya maine. So this guy would be 24m. This guy would be 16m by 5. My mistake. I need to put an extra 4 here. So acceleration will be 24m by 5. That would be how much? G by 5. That will be the acceleration. So basically that will be the acceleration of the police, isn't it? You're replacing this whole thing with an A1 block M1, M2, right? So this whole system is going up with this G by 5. So this would be the acceleration of the police. And you can see who dominates actually. P2 is going down. P1 is going up. Is that clear, everyone? The acceleration of this system is nothing but acceleration of the pulley, right? Because this string is connected to the pulley only. And what about the tension? Tension would be 2 M1, M2, G by M1 plus M2. How much is this? 1m will cancel, 5 will cancel, will be with 2 into 16 into 24 mg by 5 into this 16 plus 24 is 40. 8 2s are 8 5s are 24 to 48, 96 mg by 25. Is that right? Everyone clear with that? Tension aa gaya. So what? Now, Abhina, if you got the tension here, means I found this tension, isn't it? If that was the tension, this will become T by 2, T by 2. Agreed? So once I got the tension here, that will become T by 2, T by 2. Numbers are bad. Okay. Then you're done actually. After that, what do you do? Acceleration for each one. So this block is mg. Let this be a1. Let this block be 4 mg. Let this be a4. This block be 3 mg. Let this be a3. This block is 2 mg. Let this be a2. You don't worry about the sign. Science will take care of it. So what you want to find? You want to find a1. T by 2 minus mg is equal to ma1. Take t, substitute here. You will end up with 96 to 48 mg by 5. M will cancel. 48 g by 5 minus g is equal to a1. So how much is this? I'm getting a very, I'm goofed up somewhere. This is 25. Yeah. How much is this? 48 minus 25, 23. 23g by 25. Is that making sense? So once you replace that whole pulley with this thing, blocks, you'll get tension. What do you want to find? You want to find A4, then same story. T by 2 minus 4 mg is equal to 4 ma. We'll get A4 is equal to T by 2. That is 96 by 4. 48 by 4. So that is 12. G by 25 minus G. This is minus 13 G by 25. Minus indicator is not going up, it is coming down. The signs will take care of it. T by 2 minus 2 mg is 2 ma1. Substitute the values there. T by 2 minus 3 mg is 3 ma3. Is this clear, everyone? Can we say mass of P1 is 5 so the force acting is a force of Vihan, is that what you learned in the last class? Did you even bother to see the notes, or then why didn't you do that here? This thing then, since there is m and m, why didn't you take this as infinity? You should have taken it as infinity, right? Life would have been easy. Why to do all that, right? Then ये question क्या था? This cannot be treated as mass of 3m. Why did we write all this? Why the hell do we need to prove this pulley equivalent method? So there, so be careful. All clear with this? So if you have pulleys like this, you can replace them with blocks, fine tension, finish it off. So this pulley equivalent method works, but not every time. If I give you something else like weird, this will go off. For example, something like this. This you have seen before in constraints and equilibrium also. Let's say this is capital M. This is small m. Find the acceleration of the blocks. Now there's no pulley equivalent, nothing here. So you have to go back to the standard process. What is the standard process? Choose your system, draw the FBD, assign accelerations, find relation between them, apply forces, resolve forces along x and y, right? Apply F is equal to ma and solve. That will always work. So the shortcuts which I teach you, they will work only for some specific cases. So be very clear when can you use and when you cannot use. If you try to apply every formula everywhere without understanding when to use and when not to use, you will have a problem. Let's get this, everyone. Let's see. Step 1, choose a system, draw the FBDs. I'll start from here. Let this tension be T. This guy would be mg. This would be T. This would be 2T. This would be 4T. This would be 2T. And this would be 4T. Assign accelerations. I will assume this guy is coming down, A1, and this guy is going up, A2. Find relation between them. String constraints. 70 into minus A1 plus T into A2 equal to 0. So A2 is 7A1. Then write force equations. T minus mg, that is small m, is equal to small m into A1. This guy would be capital Mg minus 70, or I can just keep normal only. 70 minus capital Mg is equal to m into, this is A2 actually. M into minus A1. I took up positive, down negative. So take this A2, substitute here. So T would be Mg plus 7 Ma1. Take this T and substitute here. 7 Mg plus 49 Ma1 minus Mg is minus Ma1. A1 would be 7 Mg minus Mg by, there was actually M minus 7 small mg by M plus 49 small m. Check. There, I didn't teach you anything new. Choose a system, draw FBD, find constant equation, solve. Brute force. Matlab, this process will always work. Clear, everyone? Next one. Any doubts on this? So the standard stuff is there. So the shortcuts, use them only when you are pretty clear if it matches the conditions. You just cannot use any shortcut anywhere randomly. Now, this thing is again another kind of shortcut, but it's a little lengthy. So let's see what is this. Consider we have n strings. With tensions T1, T2, so on till Tn. attached to n different blocks. Let's do one thing with n different blocks. Let's say C1T, this is the tension in the first string. Proof is not important. Now, what is first string? Your choice. You call any string as first or any string as second, and so on. So if I take C and T, this will be the tension in the nth string, and C1, C2 are the coefficients. So here Cn is the coefficient of tension for the nth string. And let Mn be the mass of the nth block. An be the acceleration of the nth block. So we are trying to derive a general formula for n blocks. Technically speaking, I really don't like this, but it is useful in certain cases. When they really make it pretty complex, it is useful. This thing is literally like, you remove everything that is there to think and put it in one formula. Now, if you apply the power method says what? T1, A1, tension acceleration. So C1, T, acceleration. So T1, A1. Second one, C2, A2, T2, A2. So on, Cn, T, An equal to 0. This is your first equation. Remember, this is valid only when only strings are present. And tension is parallel to acceleration. And angles are 0. Now, if you take any one block, Mn, what are the forces acting on this? C into Tn, the tension. This would be Mn into G, and this would be the acceleration. So we get Ctn minus Mng is equal to Mn into An. So from here we get acceleration An would be Cn by Mn T minus G. This is your equation 2. Now we will take equation 2 and put it in equation 1. Are you getting this equation came from the power method, right? T1, A1 plus T2, A2 and everything. This is just a general force equation. Now if you take this An and substitute in that equation, you will end up with C1T. What is A1? A1 will be C1T by M1 minus G. So substitute there. C1 by M1 T minus G. The second will be C2T will be C2T by M2 minus G. So on. CNT by Mn minus G equal to 0. Just take out everything in common there. So you get C1 square by M1, C2 square by M2, so on till Cn square by Mn का tension square minus C1 plus C2 plus so on till Cn का tension into G. From here, I'll get the tension T will be C1 plus C2 plus so on till Cn into G by C1 square by M1, C2 square by M2, so on till Cn square by Mn. Sigma Ci G sigma Ci square by Mi. This will give you the tension of any string that we have chosen. What is T here? T is the tension which we have chosen. This is the tension in any string of our choice. Literally what we did, right? We just simplified every damn thing and we just kept it there, constraint, force equation, everything written. This will give you the answer. So that sigma I is a coefficient. So tension will be sigma coefficient of tensions. I'll give an example that will make things clear. Into G by sigma quotient of tension square by mass. You can just put it down, write it down. Let me show you in the next page an example. Like I said, derivation is not important. It's okay if you don't remember this also. You can solve it normally. Most of the questions you can solve normally with the method that we did. But if you can remember some questions, right, it will just make your life easy. You will get the answer without putting too much effort. So it's like, this is the third shortcut I was teaching you. The first thing was the net pulling force method. That is still fine. Second thing is a net pulley method. That is also good. This is like, literally you just simplified everything. Clear? Now let me show the example. Okay, what do you mean by the C1, C2? What is all this? Example, let's take the problem which we did. Three M, 2M, and M. Okay. So you want to find the tension in any string. So let's start somewhere here. Let this tension be T. If this is T, this is T, this is 2T. Agreed? So how many tensions are there? 3. So what is the coefficient for this? This coefficient of this tension is 1. It is 1 into T. This coefficient is also 1. This coefficient of tension is 2. Is that making sense? The coefficient is simply tension ka pehle what you have. Now in that formula, we have tension is sigma Ci, sum of the coefficients by G, by sigma Ci square, coefficient square, by the respective mass. Okay, so in our formula, we have, for the first block, the coefficient is 1. Second block, coefficient is 1. Third block, the coefficient is 2. By the first block, a coefficient is 1. So 1 square by mass is m. Second block, a coefficient is 1 square by mass is 2m. Third block, a coefficient is 2. 2 square by 3m. You're getting how we are using that? So t ke pehle jo coefficient tha, that coefficient we are taking. Then simplify this. How much is this? This is 4g by 3 by 2m plus 4 by 3m. M will go up. So that would be 4mg by 9 plus 8, 17 by 6. So tension will be 24 mg by 16, 17. I got the tension. You want to find acceleration for some block? Let's take 3m block. 3m block pe tension is 2t. Mass is 3 mg. I'll take acceleration up. So 2t minus 3 mg. So once you got the tension, you can find acceleration in every string, every block, 3 ma. Substitute here. 48 mg by 17 minus 3 mg is equal to 3ma3. We'll get a3 is equal to minus g by 17. It's going down. Isn't that the answer? They got tension 24 mg by 17, acceleration minus g by 17. Is this making sense? This will literally skip everything. FBD, GIFBD, constant, everything is gone. This is like, you take a sugar cane, put it in a machine, and just extract the juice. Matlab, you don't care what is happening. You get the answers. Understood how they got the tension? So that C1, C2, C3. Now, if you say like, sir, I will take this as tension. You want to take this as tension. Kuch problem nahi hai. Then this will be T by 2, T by 2. Then what will be the coefficients? 1, half, and half. Put it there. You'll get the answers. Meaning, but you will get this time, this tension you will get, isn't it? Whichever thing you took as T, you will get that tension. Is this making sense? So this will give you answer much faster if you can remember that. Clear? Now let me take something more complex, so you will see why this will be useful in that way. Now if I give you something like this is weird. Pulley, strings, this looks complex. So, but if I simply ask you, find acceleration of the 2m block. This method is quite useful in this way. Matlab, I don't care what is happening with everyone. Now, if I try to do this, I have to draw 4 FBDs. I can't use pulley equivalent method. I can't use net force method. Both the shortcuts will fail. Nothing looks similar. This will work. When will this method fail? That's what I'm saying. It is important you should know when things fail. This method will fail in this problem. If you have angles, this will fail. I hope you're getting it. So be very careful. See, whenever you're getting a shortcut, there is always a payoff. You will not get anything for free. If you're getting something very fast, that means it will have its own restrictions. If some method is giving you answers for everything, that means that method will be longer. Like the general method I teach you, draw the FBD, write the equation, so that will work for everyone. But some questions will go quite lengthy. Now let's try to use this shortcut thing and see what we'll get. I want to find the acceleration of 2m. So better would be take that 2m ka tension as T and start from there. Two by 9g upwards. Okay, let's see. I don't know the answer. So let's start from here. Let this be tension T. If this is T, this is T, this is T. So this guy will be 2T. This guy will be 3T. This will be 2T. So this will be 2T. So this coefficient C1 is 1. This coefficient C2 is 2. This coefficient C3 is 3. This coefficient C4 is 2. Got the coefficients. Then tension ka value is sigma, the sum of the coefficients into G by sigma coefficient square by mass mi ka summation. So 1 plus 2 plus 3 plus 2 by, this is 1 square by 2m, 2 square by m, 3 square by m, 2 square by m. That would be 448 mg by, this is half plus 4 plus 9 plus 4. Uh, how much is this? 4, 4, 8, 8, 9, 17, 35. It will go up. 16 mg by 35. Then you want 2m ka acceleration. You know tension ka value. You know the weight 2 mg and you have taken it up. You assume any direction. The science will take care. So T minus 2 mg is equal to 2 m. Substitute here. 16 mg by 35. The 2m will cancel. You end up with 8g by 35 minus g minus 27g by 35. Yep, it's going down. Clear with the steps. Saves you time. You try to do this normally, 4 FBDs, one constant equation, solve. You'll get the answer. Answer, you will get it. A1, A2, A3, A4, then 4 equations, then you have to substitute and then you will get the answer. Saves you time, nothing much. It's not like you can't do this normally. Clear, everyone? Then let's say we have a block M. Find the acceleration of the blocks. All pulleys are massless. Try. Just you'll try and be back in a minute. G by 9 4 G. This is a trap, Ray. This is a trap. Even before applying the formula, there's a contradiction in the problem. See, that's what I said. The formula is great, but look at this. If I start with this as T, this would be T, this would be T, this would be T, this would be T, this is also T. Now, if you take that pulley there, we have a problem. If you let's call this P1. If I draw P1 here, look at the FBT. This is T, this is T, this is T, and let the pulley acceleration be AP. So 2T minus T is equal to mass of the pulley into acceleration of the pulley. But mass of the pulley is 0. Therefore, T is equal to 0. You're getting the point? See, two strings are balancing one string. So this should be 2T, right? But it is the same string. So it should also be equal to T, right? You're getting the contradiction? This system is saying T plus T, this should be 2T. The system is also saying because it's the same string, it should be T. How can 2T be equal to T? There's only one possibility if T is 0. Is that making sense? So this system has zero tension. All the strings will be loose at this instant at least, and tension is 0. Therefore, all blocks will have a free fall. Acceleration is equal to G. A is equal to G for all blocks. The strings will just become loose. Clear? So that formula is great, but the problem is this contradiction. That system is saying it should be T and 2T at the same time. So be careful. Clear? Next one. Easy one, but yeah, you should know like there's a contradiction. It's a model. This we have seen. This is the third time you're already seeing in this chapter. Find acceleration of the blocks. All surfaces are smooth. You know the steps. Choose a system, draw the FPD, SN acceleration, find relation between them. Apply F is equal to ma along x and y and so on. The process will never change. You see something which is not looking weird, you go to the process. Try. I'll give 3 minutes. Answer comes in also small m and capital M. Step 1, FBD. Check whether you got these things right. In the FBD, you always include the pulley. Tension, 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 normal reaction, your own weight, and on the ground. For the small block, tension, normal reaction, mg. Accelerations. If this goes with A, this will go with A, and this will go down with 2A. Remember? This will go with 2A downward. This we did in method 3. This was the question. You can refer page 38. Same notes. Do you remember? Because whenever this thing goes forward, this string and this string both are getting loose. No? Two strings are getting loose. So this will go 2 times the distance downward, and horizontally it is getting pushed. That will be the acceleration. Most people go for that part. If you got till here, question is over actually. Writing FBDs and the constant is the main thing. Forces. 2t minus normal reaction is mass into acceleration. Here, T minus mg is equal to mass into minus 2a. Horizontally, n is equal to m into a. So T will be mg minus 2ma. N is equal to ma. Take this and substitute here. Take this and substitute here. You end up with 2mg minus 4ma minus ma is capital Ma. A is equal to 2 small mg by m plus 5 times small m. That's it. Check. If you know your FBD, if you know your constraint, there's nothing in the question. Not only this, any equation, that's the main thing. Most people don't know how to put FBDs properly, don't know how to put constraints properly. After that, it's just a matter of writing equations and solving. That is all max part. That's the reason we spend so much time on constraints and free body diagrams. Clear? Let's see one more. Any doubts on this? Next one. This also you saw this. This is M. This is also M. I'm taking same mass, theta. All surfaces are smooth. Find the acceleration of the ball. Now no one is holding it. They just left it. So this will start sliding. Let's find acceleration of the wedge. दोनों आ जाएगा. Reward diagram, relation between accelerations, equation solve. Let's see. First thing, step one, free body diagram. What are the forces? Normal reaction, your own weight mg, n ground. This is theta. If that is theta, this is 90 minus theta. That is theta. This is theta. So this is 90 minus theta. This is 90 minus theta. This is theta. Hope the angles are clear. Components, this would be n cos theta, n sin theta. For the ball, that same n will act here. This would be n ball. Your weight is mg. That is theta. You can get the same components here. This would be n cos theta. This would be n sin theta. Third law. If this is n cos theta, the up should be n cos theta. Forces are done. Next thing, accelerations. Let this guy go a1. Let this guy go a2. Rigid body constraint. This is your normal. This is going with a2. This is theta. So this component is a2 cos theta. This is going with a1. This is 90 minus theta. So this is a1 cos 90 minus theta, a1 sin theta. Along the normal accelerations must be same. a1 sin theta is equal to a2 cos theta. This also we did. Therefore, we get a1 is equal to a2 cot theta. So let's say a2 is equal to a1 tan theta. This is your step 2. Find the relation and find the relation between the constraints. Now write the force equations. For the wedge, horizontally, n sin theta. That's it. There's no other force, ma1. And for the ball, if you see vertical direction, mein n cos theta mg minus. This is for the wedge. And for the ball in the vertical direction, mg minus n cos theta is equal to ma2. For the wedge, I'm writing in x direction. That is because they're only moving in that direction, right? Why to write in the direction when they're not moving? Done, you got everything. Dal the abhi values. So take n from here. ma1 by sine theta. Take this and dump it here. You'll get mg minus ma1 cot theta ma2. a2 is again a1 tan theta. Bring all a1s to one side. M will cancel g by cot theta plus tan theta, which is nothing but sine by cos, cos by sine. That will be g sine theta cos theta by this would become cos square theta plus sine square theta, which is 1. So a1 would be g sine theta cos theta. You can simplify further, multiply and divide by 2. So g by 2 sine 2 theta. There you got a1, a2 aa jayega. That is a1 into tan theta. a2 will be g sine theta by cos theta, so g sine square theta. Is this clear, everyone? Did I do anything new? You know how to draw FBTs, right? You know how to find the relation between constraints. You know how to write equations. It is just a matter of solving. Every basic step how to handle you have learned. Have a look at this. Ask me if you're still confused with any particular step here. All sure with this? Next one. Yeah. Next thing. Weighing machines. So what does a weighing machine measure? What does a weighing machine measure? What do you think it measures? It measures normal reaction. And it shows what it measures and what it shows are two different things. And it shows a reading which is given by normal reaction by G. So whatever it measures, it'll divide by G and give it. Example, let's say if you have a weighing machine like this and someone is standing on it, let's say system is at rest, and let's say this guy weight is 50 kg. So if you draw the FBD of the man, the normal reaction is N, this is 500, so N is 500, so the reading of the weighing machine would be N by G. I'm taking G, like 9.8 or 10 doesn't matter here. That would cancel out anyway. So this would be 50G. So N would be 50G. So this will be 50 kgs. Kind of makes sense. But let's say if you take this person and put him in a lift. And let's say the lift is going up with 2 meters per second square. I'll take G is equal to 10. Now, if you draw the FBD of the man, normal reaction, let's say the same man, 50 kg ka weight, that will be 500, and this acceleration is equal to 2. So N minus 500 is equal to mass into acceleration. N will be 600. So the reading of the weighing machine will be 600 by G, which is 10. So it will show actually 60 kg. Are you getting it? The weighing machine doesn't measure your mass. It doesn't know what is your mass. It measures normal reaction. So if you're accelerating or decelerating, normal reaction will get messed up. And the weighing machine will start showing different readings. This is what you experience when you're in a lift. When the lift suddenly starts moving, you feel a little, jerk kind of thing. Or when you're going in an aeroplane, when you're sitting and it is taking off, you feel that, certain weightlessness kind of thing. Or if you ever gone to Imagica, the Nitroco ride, you must have experienced it when it is just coming down. You feel that weightlessness. The normal reaction is 0. Is this clear, everyone? What does a weighing machine do? Clear? Let's see a question how they'll frame on this. Yeah, if the lift comes down, then normal reaction will decrease. Let's see a question. So we have a lift. So we have a man here whose weight is 50 kg. So when the lift goes up, with A, it shows reading M1. When lift goes down, same acceleration with A, it shows M2. And if M1 by M2 का ratio is 3:2, find A. So this person is placed in a lift and you got a weighing machine. When it goes up, I think you don't need that 50 kgs also. Let it be M. Let the mass be M. When the lift goes up, it shows M1. When the lift goes down, it shows M2. Same acceleration. And M1 by M2 ka ratio is 3:2. Find A. So straightforward, when it goes up, N minus mg is MA. Let's call it N1. So N1 is M into A plus G. When this guy is going down, then N2 minus mg is equal to M into minus A. So N2 is M into G minus A. And indirectly, he gave you N1 by N2. The reading is 3:2. So G plus A by G minus A is 3:2. Cross multiply. You'll get A is equal to, how much is that? 2G, 3G, G by 5. 2 meter per second square. Clear? All got this? Let's see one more. Like straightforward.
Sir, can you show the previous slide for a minute?
Yep. Well, I didn't write all the forces. So this is N1, this is Mg, this is N2, and this is Mg.
Thank you, sir.
This is a HCV question. There, this was the diagram. So we have a man here who is standing inside a lift and he's holding the lift with a rope, which is only holding it. There is a hole here on the lift, so he's holding it like this. So the first question, if the man manages to keep the box at rest, what will be the weight shown by the machine? Second question, what force should he exert on the rope to get his correct weight? Man of mass 60 kg, box ka weight is 30 kg. There, read the question, get this. The first part, he is keeping himself at rest. So if you just draw the FBD of the whole system, now what will the system think? There is a tension here, there is a tension here, isn't it? Does it care whether who is there or what? It simply thinks there are two strings, isn't it? I'm taking the whole box as a system. And what is the total weight? Total weight will be 60 plus 30, 900. So tension will be 450 newtons. Now, if you take the FBD of the man, what are the forces? String is pulling up, his own weight is pushing him down, that is 600. And this is a normal reaction. The normal reaction would be 150 newtons. Therefore, the reading would be 150 by G, 15 kgs. Because if you take the whole thing as one system, if you want, you can take the box and man as two systems and solve, you'll get the same thing. But if you take the whole box as one system, I don't care what is inside. All that I see is there are two strings pulling up and there's a total weight 900. I'll get tension pretty fast. The second part of the question, how much force should he exert so that he'll get the correct weight on the machine? Now try to understand, if he applies more force than this, the block will start, this whole system will start going up. He's not at rest. Try. 1800, okay. Let's see. Zero, they will fall down, right? Now, so the whole thing is system tension. Your weight is 900. The system is accelerating. We don't know how much now. So this will be 2t minus 900 is equal to 9a, 90a. That is the first thing. Now, when you draw the FPD of the man, the forces will be tension, his own weight 600. The normal reaction is also 600. Since he's measuring the weight to be proper, n should be 600. N is 600 since the machine measures the correct weight. That means tension is equal to 60 into acceleration. Take that and put in the first equation. You end up with 2 into 60 a minus 900 is equal to 90a. This would be 120 minus 90. 30a is equal to 900. A is equal to 30 meters per second square. With that acceleration, it should go and substitute there in t is equal to 60a. That would be 1800 newtons. If this guy has to apply this much force, then the whole system will go up with 30 meter per second square, that is 3g. And then the machine will show the correct weight. So if he applies more force than that pre 450, what he is applying before, the system will not remain at rest. Clear with this? Any doubts on this? We're just clear with this. Hope everyone has solved the last week ka paper. There are solutions also provided, so make sure to go through them. We'll be discussing it on Thursday in case you have not solved it. Make sure to finish it off. It's a good paper. Tough laga? It was a little tough. Yeah. Let's see one more. Let's say we have a weird incline like this. And we have a rope like this. So this is a rope of uniform mass. Which is given by lambda, which is mass per unit length. This is called linear density. The regular density which you studied in school, right, is called volume density, mass per unit volume. What is the meaning of this? Example, if someone tells you lambda is 3 kg per meter, the meaning of this is 1 meter rope ka mass is 3 kg. If you take 10-meter rope, mass is 30 kg. Right, and let's say this thing is tied by a rope here, and this thing is tied by a rope here. Let's say this tension is T1, this tension is T2. The only information you know is the height h and the base length L. Find T1 minus T2. It's an equilibrium. Surfaces are smooth. The difference in tension between the upper and the lower end. The end result is good. mgl by l square plus h square. What is m here? What is m? Did I give you that? कहाँ पे था? You guys now have a habit of giving answers in some weird variables which I didn't give you. Where did I give mass of the rope? I give you mass per unit length. Did I give the length of the rope? I didn't give you length of the rope. I didn't give you length of the rope. So you can't find the mass of the rope. I don't know what's the mass of the rope. Listen, this is a little weird. Listen to this carefully. We'll again encounter a similar problem in friction. So these kind of questions, right? The idea is so consider a very small piece here, ds. Okay, get a small piece there, ds. So what is happening here? The tension, if you look at this, and let this be angle theta. It's like an incline. And remember, theta is variable. At every instant, you have different thetas. So if you just look at that small piece here, it looks like this. So this length is ds. And if you look at the forces now, there will be a tension T plus dt. Tension will not be same. It will be different on both the sides. This is T. So we are assuming the tension is increasing by small amount dt for a small length ds. And if you look at the forces here, this will be dmg sine theta. This would be dmg cos theta. And this would be the normal reaction. It is, we are just treating it like a small block. So we consider a small length ds. Since it is so small, you can treat that like an incline. dm is the mass of that small piece. How much is that? dm will be lambda into ds. Lambda is mass per unit length into length. And here dt is the small change in tension. Because of that small mass, there will be a little tension. Tension will increase by small amount. This is the change in tension due to ds. Now, if you look at the forces here, T plus dt is balancing out T plus dmg sine theta. Is that making sense? Because of dmg sine theta, you're getting this extra tension, right? Sure, everyone. The dmg cos theta is balanced by normal reaction anyways. Tt will cancel. So we get dt is equal to dmg sine theta. So we have dt, dm is nothing but lambda g ds sine theta. Please have a look at it here. So you took a small rope randomly somewhere on the string. I don't know where, anywhere you could have taken it. Theta is changing every instant. You took a small piece ds. Because of the small piece ds, you get a small weight dm, and that is generating an extra tension dmg sine theta. So all this small tensions will add up, and that is the reason you're getting different tensions. Someone has to hold right here, or else the whole thing will slide downward because it is smooth. Have a look at the steps.
Sir, can we just find the length of the rope? Then we'll just know the mass.
But how will you find the length of the rope?
So, sir, there is no way to evaluate dl by dh.
Let's see. You can't. You can't find length. How will you find this curve? I gave some random curve like this, right? Clear this?
Yes.
Then, so we got dt is lambda g ds sine theta. Now understand, I don't know ds, I don't know theta. Now on this small piece, when you took this as ds, This was theta. The horizontal distance was dx, and this was dy. From here, we can clearly see sine theta is dy by ds. So ds sine theta is dy. So we get dt is equal to lambda g dy. Now, if I integrate this on both the sides, integral dt lambda g dy, this will go from 0 to h. So at 0, the tension is T1. At the topmost point, the tension is, I wrote reverse. At the topmost point, tension is T1. At the bottommost point, tension is T2. So we get T1 minus T2 is equal to lambda g y. Limits will go from 0 to h. T1 minus T2 is lambda g h. The difference in tension depends only on the height, independent of the rope ka shape, rope ka, doesn't matter, length, anything. So the general result is this. Suppose if you have something like this. And let's say you have a rope on this kind of surface. I didn't draw that properly. It's a uniform rope. And let's say at this point, this height is h1. This height is h2. This point, the tension is T1. This point, the tension is T2. The difference in tension T1 minus T2 is lambda g. It simply depends on the difference in height. h1 minus h2 is the difference in height between the two ends. It doesn't matter about the shape. It doesn't depend on the length. That would be a most general result. Is this making sense, everyone? Now, logically, if you think about that also, the reason is this, I'll tell you, see. All the weight that comes, right, is only because of the vertical weight, isn't it? The horizontal components will anyway cancel themselves out. But it is a little difficult to figure out, but you can see from the integration, the difference in tension depends only on the dy, that is the vertical height. It doesn't depend on the horizontal distance. This is a more general result. Have a look at this. Main thing, this should be smooth. You take any shape, it should be uniform rope. Put it on any kind of weird shape, the difference in tension will be depending on the difference in height. Is this clear, everyone? For example, if I tell me what will be the answer for this guy. Let's say we have a cylinder like this. Fixed cylinder. Someone kept a rope like this. This rope is fixed to the wall. Let's say lambda is 10 kg per meter. The radius of the cylinder is 2 meters. This angle is 60 degrees. Find tension. This is a smooth fixed cylinder. Suppose if I cut the string, won't this rope will simply slide down? If I cut the rope, this will simply slide down, isn't it? We can do this as a question. Let's get this thing, find tension in the rope. Gravity is there. So that rope is simply hanging there. The topmost point is this, the bottommost point is this. So a part of a rope is hanging on the smooth cylinder. You tie it with a rope on the left hand side so that it doesn't fall. Lambda is 10 kg per meter and radius is 2 meter. So using this data, find the tension in the string. Okay, so first thing, see, so this was the rope. Now you need to understand this is tension T. Here there's no tension, okay? This is T0. Why? It's a free end. There's no rope, nothing. You didn't tie it to anyone. Free ends mean the end is simply just loose there. So free ends have zero tension. Think about it. If there is a tension there, whom are you pulling? There should be something to pull, right? Here, mass. So that will have a so T2 is 0 here. So what you're interested is only the height, isn't it? So this is 60 degrees. So we want to find this height here. So if this is R, so this would be R cos 60, which is R by 2. So this is also R by 2. This is your difference in height. So you're done. So T1 minus T2 is equal to lambda G, the difference in height. So T1 is T, this is 0. Lambda is 10 kg per meter. G is 10 and delta H is R by 2 and R is 2. 100 newtons. Easy. If you try to do this normally, you have to integrate. And the best part about this question, I could have taken any weird shape. I could have put in rope here, and as long as this height is half meter, meaning R by 2 meters, the answer will be same, isn't it? It doesn't matter about the shape. Only what depends is the height, independent of the shape. So that is one more thing. This is independent of the length and the shape. Shape of the path. Is this clear, everyone? So that is one part of it. So the next part of the chapter is springs. So next class when we catch up, we are going to continue from here. We're going to do springs, and then we have something called pseudo force. Mostly we should wrap up another 1.5 class. And then after that, we'll start off with friction. So you can start doing like a booklet, whatever you're doing, do finish it off. Don't take too much time. I think after this Thursday, you'll be able to handle everything. So try to start solving, finish off as much as you can. We almost touched 49 questions. So we did a good number. And do resolve the paper, right? On Thursday, we'll be discussing the paper in detail. So paper is tough, but I think if you had enough time, maybe you would have done it. That's what I'm saying.